Hey guys, I'll be covering hydroelectric power basically in this section, which is pages 283 to 284 in the which book is this? Yeah, the Pearson book. So yeah, so essentially, what they want you to know is that all the energy on Earth comes from the energy of the sun, essentially. So what that means is you need to know the water cycle. So just a brief overview of the water cycle, which you guys should already know, but just a brief overview. There's a large water body. So first we have the concept of evaporation, where when sunlight heats up, water in the water body, and it evaporates or turns into water vapor and then rises up because hot air rises. And as it gains altitude, it gets to a cooler temperature where it condenses, which is the second step, condensation. So when it condenses, it forms clouds. And when condensation keeps happening, the clouds become heavier, and then that leads to precipitation, which is basically just water falling down in the form of snow, rain, or hail. It's just basics. Okay, so that was just the basic water cycle. So this is just the transfer of energy that we're showing here. Also know that water at high ground has energy. So we know this from potential energy. So PE, or potential energy, actually let me write the notation that IB uses. They use EP, subscript, equals to mgh. So let's just define our variables. This is, of course, potential energy. Potential energy. M is the mass, in this case of the water, in kilograms. By the way, this is in joules, by the way. So M is mass in grams. G is the gravitational constant on Earth. So if you were on another planet, then you use the gravitational constant for the other planet. But you don't care about that because they don't have water on other planets for now. So this is 9.8 meters per second squared. It's constant. And H is the average height of the water. Now all the water will not be located at one height, so we just take the average height, the water. Average height. Let's leave it at that in meters. Essentially, that's what you have. So water, because of its height, because of its location, will have a certain amount of energy, and that energy can be harnessed. So there are various ways to do it. Water is collected from, it's made to flow from higher ground to lower ground, and when it comes to the bottom, it turns a turbine. And the turning of that turbine, as we know from previous sections, creates electricity because there are small magnets attached to the sides of the spokes, I guess, of the turbine, and that creates energy, electricity, form of electricity. So that's about that. So you can pause this here if you want this. I'm going to erase it. So there will be a lot of, for this section, it just involves problems related to the calculating potential energy. Let's see. So essentially, if you have already water existing at a high temperature, higher altitude, at a height, such as in Norway, for example, they have a lot of high altitude lakes, then you're good. But if you don't, then you generally build dams on a river or something where water is constantly flowing. So it's the same concept. Water flows from higher ground to lower ground, and it turns a turbine. and that's how you get energy. The next thing in this section is a pumped storage system. So basically, it just refers to this fact that the demand for energy is not the same at all points of time, essentially. For example, you need more energy during the day than at night, because you're sleeping at night generally. Yeah. So what do you do then? You can't just stop water. That's not how it works. Rivers just don't get stopped. So to deal with that, they have come up with this system that the excess energy that is produced, the excess energy that's produced in this pump storage system. Is it pump or pumped? It's pumped. Sorry for that. Pump storage system. So the excess energy that is produced in this, it just uses, it's used to like bring the water from the lower altitude that you're not using to a higher altitude so it can be used again. So it's put into a more constructive use, let's just say. And basically that covers it. So